In our last video, we did a couple of tests. So in this video, I promised that we were going to do more tests. So let's conduct some more tests on our airdrop smart contracts. So when we deploy this contract, when we deploy this airdrop test, this contract is now deploying this contract. This airdrop test contract is deploying the whole token, is deploying the reward token, is deploying the airdrop token. So in our next test, we are going to be checking for the owner of the airdrop contract. So if this contract airdrop test deploys, we are deploying this airdrop test. So this airdrop test now is now deploying all these tokens, and for these tokens now, this whole token, reward token, and airdrop app, the owner of this airdrop app is going to be the airdrop test contract. So we want to assign our own custom address to this airdrop app. We want to create our own address so that we can be able to use it to deploy this airdrop app. So we are going to do we're going to be adding one special keyword console. So we can be consoling some details on the terminal. So we are going to do, so let's search for make ADDR. So this make ADDR is a special cheat code in Foundry. It takes in a string memory name, then returns an address. So it generates a dummy address for us to use to test our smart contract. So let's make a dummy address that we'll be using to deploy this airdrop app instead of using this airdrop test. So we're going to do address. We're going to name this dev equals to make ADDR. So we're going to get a name dev. So we're going to be logging out the dev token. So we're going to be doing here console.log. We're going to be returning the dev. So we want to see the accounts that this make ADDR created for us. So what we're going to do is that we're going to do a forge test. I'm going to use VVVV. So what this V does is to give more details about the transaction, about the test, everything that goes on the test. So 1V, 2V, 3V, 4V, you can do it up to 5 Vs. So let's write our test. We are just caring about the address that it's going to create for us. Okay, you can see the address it created for us. So this is the address it created for us. So for us to make this airdrop app, for us to deploy this airdrop app by our own custom address, we are going to be using a cheat code in Solidity called prank. So let's look for prank. So you can see prank. Set message or send that to the specified address for the next call. So if I do a prank dev here, vm.prank dev. If I do a prank dev here, I'm just saying, hey, um, I want this hold token. I want this transaction next to be performed by this address. That's what I'm saying. If I do it here, I'll be telling the contract that, hey, I want this address that we just made to be performing this next transaction. Same way, if I do it here, I'm telling this transaction, okay, the next transaction, please do it for us. So I'm going to just grab this because we are just going to be testing the airdrop app. So I'll paste it here. So what I'm saying is that, okay, we don't want airdrop test to deploy this airdrop app for us, so that the owner of this airdrop app will not be the airdrop test. So once this dev, our own account, to be the owner of this smart contract airdrop app. So in order for us to know whether it works or not, we are going to be we're going to be logging the owner of this airdrop. We're going to compare it with the dev account. If they are the same, then our code is working as expected. So we're going to do console.log. We're going to do airdrop.owner. So we're going to run our forge test. So we're going to run forge test. So okay, you can see the both address are the same. Both our dev address and our owner of the airdrop app. So we got it correctly. So we are going to be testing that I'm going to be running a test. We're going to do a function test owner is correct, public. So we're going to be doing we're going to be doing an address. I don't want to add code editing, so I'm going to do airdrop dot owner. So I'm declaring local variable which stores the address of the owner of the airdrop app. Then we're going to do assert dot equal owner must be equal to dev. Right. So we're going to check if this is correct. The address owner and the dev owner, if they are the same. So run a forge test. This time I won't be needing the VVVV, so we just deploy. Just run the test script. Okay, sorry, I forgot to add owner. So yeah, to do a forge test. So I test passed successfully. Test owner is correct. Passed. So okay, so we are going to claim the tests. Sorry, we are going to claim check the claim button. So we can check. I'm going to do function test. I'm going to do check claim. We just check claim. So this is going to be public. Okay. So before we check the claim. Remember that this dev address is supposed to hold some certain amount of the hold token. So we are going to be sending him. We are going to do a hold token dot transfer. So we're going to be sending him the transfer. We're going to be sending dev. So we're going to be sending him 8,000 token. 1,000 token multiplied by 118. So right. So we transfer some hold token. So and we're going to be sending some reward token to we're going to be sending the reward token to our airdrop contract. So we're going to be doing this after we've deployed this contract. So we're going to we'll come under airdrop. Then we'll do reward transfer. We're transferring to airdrop. We'll convert it to an address type. Remember. Airdrop. Right? Then we're transfer basically everything. Okay. 1, 2, 3. Then multiply by 1 is to power 18. Right? I think we are good. Yeah, I think we are good with our setup. So what basically we sent some reward token to the airdrop app so that the airdrop app will be able to distribute effectively. Then we send some token to the dev hold token so that the the test won't fail. So we are going to do we're going to do a VM transfer rank. So once we want the dev to be sending this transaction. So we'll do airdrop dot claim. So we don't currently have any ether in this claim. We don't currently have any ether in our dev account. So what we're basically going to do now is to we'll use the cheat code called lock. I'm going to search deal. So I'll click on deal. So deal set the balance of an address hold to a new balance. So it takes into parameter the whole and new balance. So before the prank, we'll do a deal. So we'll do a VM dot deal. So takes in a dev. We will set the 100 ether. So that we'll have enough balance to claim. So before the claim, we'll be saying value. Value is going to be what's our claim amount? 5. Let me check. Please forgetting claim amount is 0.005 ether. So 0.005 and 5 was wrong. 5 ether. So curly braces, and I think that's all for that. Then we're going to be doing assets. We're going to do a uint 256. We're going to be doing balance. So we're going to be doing reward token dot balance of Okay, dev. So we're going to do assert equal balance should be equals to 2000 multiplied by 1 raised power 18. I think that's pretty much it. So we did due. We sent some ether to our dummy account. We say that okay, this next transaction claim should be performed by the dev account. Then we got the balance of, we store the balance in the unit receive variable balance of dev. Then we checking if the balance of dev is truly that amount. The reward token, if he got the balance, if he got the token. So we're going to do forge test. Okay, you can see it passed. So our 4 tests passed successfully. The owner is correct. So check claim. Okay, look at it here. Check claim. So our test passed correctly. So next test we're going to be doing is we don't want let's try to claim without any hold token. So we're going to do a function. We are going to be checking we're going to be intentionally filling our test so that it will pass. So we're checking if, what we are going to be checking is that if the function is going to fail if our dev account does not have enough ether. So test would fail not 11 rows. So this is going to be public. So we're just going to do so we're just going to copy this. So so we will not send any token. Here we'll send lesser than. We have to comment this test out so that this test will be able to run. So I'll just comment this test out because I don't want to send any token. So we're going to comment this out. So we did not send any tests, any hold token to this dev account. That's what we literally did. We did not send any tests. So this dev account does not have any hold token. So we are going to do a claim. We're going to do an airdrop dot claim. So we're going to be sending the correct amount of ether into the value. We're going to do 0.005 ether. Airdrop claim 0.05 ether. Yeah. So we're going to do assert. No, we're going to do vm dot expect fail. I think we got anywhere. So let's go and search it up. I think it's the let's do an expect. So I'm looking for the expect fail. And the vm dot expect fail. So we're going to do a vm.expect revert. So this is it. If the next call does not refer with the expected one, the reverse will. So if we are testing for a function to fail, we do an expect revert. So we're going to do a forge test VPV. If our test fails, then we are getting it wrong. But if the test pass, then we got it right. Um, Revert not eligible. It was supposed to. Let's expect revert. Yes. So this is the log for the test. So test holding, fail not holding. So you can see we try to claim we got a reverse message not eligible, but the test was supposed to pass. The test was actually supposed to pass, not fail. But I really don't know why it's so. I think we did the VM expect correctly. Expect reverse. So okay, so you get the concept. You get the concept already. This test is the last test. This test is supposed to fail because the owner is our dev is not holding enough token. So it's actually failed. So I think our test passed, but it failed. Oh, so I think we've done literally almost everything we're supposed to do. I think we've tested virtually everything. So I'm going to do a coverage. I'm going to do a forge coverage. How come getting this way? So it's going to give us like how many percent of our contracts have we tested. So it's going to bring it up like a tree, like a table. So you can see 100% of our contract have been tested. So I think we are good to go. Okay. So I think we did a lot of tests and I think we are good to go. So at least we have something to hold on to. So in the next video, we are going to be doing the front end part of this airdrop. So thank you for watching. Please like, share, and subscribe.